from smoothies. How is that okay? Sam, why is that okay? Beautifully said, Sam. My equation, my factors can kind of go sideways, diagonal, different directions. However, my product is going to stay the same. I do want a full array. I do not want a fast array. Lucy, what's up? Yes. Yes. Yeah. All right, most of you have gotten your 6x3 array. So how can you turn that into a 7x3 array? Talk to me. We're looking at a 6x3 array. How can I turn that into a 7x3 array? Alright, here's my 6x3 array. Yours might look sideways than mine. That's okay, because Sam told us the commutative property says that we can go in any order with our factors, and our product will remain the same. How am I going to turn this, Georgiana, into a 6x3 array?
Add 3 to the bottom.
Add another group of 3. Anyone wants to do that a different way? Brian?
You could add another group of 6 next to it.
Can you add another group of 6? Alright, let's find out what that makes. So if I'm going to add another group of 6,
And it's the 4x6.
what does this now become, Brian? Is that the kind of array that I'm looking for?
No.
No, so I can't add another group of 6. I can only add what?
At the bottom.
A group of what?
3.
A group of 3. Remember when we say this, we say 6 groups of 3. So to make it a 7x3, we need 7 groups of 3. I want you to make your array turn into a 7x3. I want you to circle the group that you added and then label your array. So this was a 6x3, and then all together it became a 7x3 just by adding one group of 3. If you know a 6x3 array is 18, how can you use that information to figure out a 7x3? 6x3 is 18. What is going to be the product for 7x3? Don't count all those dots all over again. You just counted 6x3 is 18. What do I need to do to figure out 7x3? Right here?
What it equals.
Well, what you're going to do.
You can look at 6 groups of 3, and then add 3 more.
I'm going to add one more group of 3 to my 18. So count on with me. 18, 19, 20, 21. There's my one group of 3. So now I have 7 groups of 3. What is 7 times 3?
21.
What is it?
21.
21. Alright, create a 6x8 fast array in your notebook. So are you going to draw all those dots? No. 6x8 fast array. Why do we use fast arrays? Why can't we use fast arrays? What's the point? Allie?
We're not just counting all the dots and
Yeah, we don't need to just count every single dot. We know better math than that. We have better math skills. Get that out of your mouth. So we can just create the outline of an array and then skip count. Okay, kind of get out of your desk. We can skip count rows, we can skip count columns, whatever works for you. How am I going to make this a 7 by 8 fast array? How am I going to make this a 7 by 8 fast array? I have a 6 by 8 right now. What do I need to do to make it a 7 by 8 fast array? Cheyenne? I'm just going to add one dot here. Because I have 1, 2, 3, 4, 5, 6 going down. Here are my 6 rows ready to go across. And I'm adding my 7. So now I have a 7 by 8. Am I really just adding 1 though?
No.
No. What am I really adding? This is a shortcut, so I only have to draw 1 dot, but am I really only adding 1? Or what am I adding? Yeah, 1 group of 8. Because remember, there are all these invisible dots going this way. It's not just plus 1, it's plus 1 group of 8. Solve that in your notebook using a strategy. If you skip counted, great for you. If you broke apart the 6 or the 8, good for you. How can I use this equation now to figure out 7 by 8? So I don't want you using break apart necessarily. I want you to use what you already know. 6 times 8 is 48. How are you going to use that to figure out 7 times 8? I like counting on strategies. Aiden, are you doing anything productive over there? Or are you just playing with pencils? Let's back up. How do I change a 6 by 8 to a 7 by 8? Dylan? Add one more group of
8. 6.
Read it. Read it. 6 groups of 8. So to get from 6 groups of 8 to 7 groups of 8, I need to add one more group of 8. This is a good one to count on. I'm going to start at 48. How many am I going to count on? How many am I going to count on, Mason? No. Dylan just told us. You're not counting on by groups of 6. You're counting on by groups of 8. Read those problems correctly. 7 groups of 8. So we're adding a group of 8. Count on with me. Count on with me. 48.
50.
51.
52. 53. 54. 55. 56.
7 times 8 is
56.
Add that in your notebook, please. Alright, we're going to go find our mini multiplication chart and see what product of 7 I have not learned yet. We did our 4s, right? We did those a long time ago. Man, I'm just lacking. Ow! Within my 7s, what 2 equations have I not done yet? In my 7s, What have I not done? You should be looking at them. I'm not saying solve them. I'm not really sure why I see so many pencils out. What have I not done yet? Your multiplication chart looks just like my multiplication chart. What equations have I not done yet? Do you remember how to read a multiplication chart? Put one finger on a factor up top, one finger on a factor down bottom. Where they meet is the product. Where are our empty boxes? This is not a trick question, guys. Your empty boxes are in this little space over here. We want to be in the sevens. So what two equations have we not solved yet? I want you to show your neighbor how you figured it out. 1, 0. All right. What two equations have I not done yet? Did we do 7 times 0?
Yes.
Yes. We do 7 times 5?
Yes.
Yes. What have I not done yet? I only have a couple of empty boxes down there. What have I not done yet? Grace, what have I not done? I have not done 7 times 7 and 7 times 8. Those are the only two equations I haven't done yet. I've done every other equation. Grace, what's up? So we know the only two equations that I have not solved are 7 times 7 and 7 times 8. What is the name for the distributive property that we call it? Because we don't use the language distributive property. We don't necessarily have to. Necessarily incorrect. The mathematical rule is called distributive property. But we generally just call it what, Courtney? No, we do not call it the commutative property. Distributive property and commutative property are not the same thing. Damien? We can call it part whole, and we can also call it what, partner? Break apart. Break apart, part whole, distributive property. Those are all synonyms in this case. So next to where you wrote distributive property, I want you to write part whole and break apart. Alright, so how can I use break apart, part whole, distributive property, you're going to get out of your desk, to solve 7 times 7? How can I use this break apart strategy to solve 7 times 7? Not a trick question. We've been doing break apart for a while. How can I use break apart to solve 7 times 7? Aiden? You have no idea what my question was. This is the issue that I have. I don't care if you fidget. I do care if you fidget and don't pay attention. So put whatever you're playing with on my desk, and I need your attention. So here's how I'm going to use break apart to solve 7 by 7. I'm going to break apart one of my factors. What could I break my 7 into? You could break it into 6 and 1. What if you're not so good at your 6s, though? Two and 5. Are most people good at 2s?
Yes.
Are most people good at 5?
Yes.
Now here's the thing when you break it apart. It has to be a part whole. You cannot just say, well, I like my 5, so I'm going to break it into 5s. Does 5 plus 5 equal 7?
No.
It's a big issue with you. You like to just put random numbers. We need to make sure that our 2 parts down here equals our whole. So let's do 5 and 2. Because I know you all know your 5s and 2s. Alright, let's write our equation. What do I need to write first? Eva?
75 and 72.
No. I don't have any 75s or any 72s. I have a 7, a 5, and a 2. That does not equal 75 or 72. Aiden?
5 times 7 and 2 times 7.
You can go in that order because we know that our equations can go in any order, but I have found it's easier if students go with the factor that you did not break up first. So which factor did we not break up?
7.
7. So I like to start with the factor I'm not messing with and then multiply it by the other part. So we have 7 times, what's one part of our other factor, Grace? 7 times 5. And then we're going to put that in parentheses, meaning that's one group. You're going to solve that section together. Plus, what's next? Nathan? 7 again times, now the other section. Put that group in parentheses, meaning, hey, solve this section together. Let's solve our parentheses. 7 times 5. I should see everybody's hand in the air because you have memorized your 5s. Kaylin? 35. Plus 7 times 2, which I should also see everybody's in the hands in the air because you memorize your 2s. Dylan? 14. Alright, now add those two products together. 35 plus 14. Says you're having a little patience, friend. Chill. 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 The world is not ending. Eva, what'd you get?
49.
What is 7 times 7?
49.
Alright, we left off yesterday and we were solving 7 by 7 and 7 by 8. And then I forgot to do this, but Grace was right. We can do both of these. If we can go for up and down and side to side, and our product is not going to change. What did we get for the product of 7 times 7? You might have to go back and look. Just put your hand on your multiplication chart and go back and look at your work that you did yesterday. What did we figure out? We used the break apart strategy to figure out 7 times 7. Just be patient. Dylan, what do we get?
49.
49. So we're going to fill in. Remember how we read this. We put one finger on one factor, one finger on the other factor, and we pull our fingers together until we get to where they meet. So this is going to be 49. Can I fill that in anywhere else? Think. Can I fill 7 by 7, 49 anywhere else? Parker, I can? Where? Where? If it's 7 by 7, it's the same number. Is there going to be another spot for it?
No.
No. All right, what about 7 by 8? If you know 7 by 7 is 49, and you want to figure out 7 groups of 8, or 8 groups of 7, I should probably say, add on one more group of 7. 49, 50, 51. Mason? It's not going to be 54. It's close. Tajir, what you got?
56.
It's 56.
Yes.
So I'm going to be able to fill it in going across. Because 7 times 8 is 56. And I'm going to be able to fill it going down because 8 times 7 is 56. We have one more fact that we have not done. What have we not done? We have done every fact except for one. Ella? 8 times 8. So that's what we're going to start with today. We're going to go to 8 times 8. Go back to your notebook to where we left off last. So as Ella just said, we looked at our mini multiplication chart, and we only had one fact that we hadn't learned yet, and it is 8 times 8. It's our last one. All right, so we're going to use the distributive property, otherwise known as break apart, to solve 8 times 8.
Okay.
So we're going to pick a factor to break apart. Which factor would you like to break apart, Gabriella?
8.
Does it matter if I do the first 8 or the second 8?
No.
You just have to make sure you're only doing one. Mathematically speaking, you can do both, but it gets too complicated, and it's just easier if third graders only break apart one. All right, so let's break apart an 8. What easy peasy numbers could we break an 8 into? Think for your own brain. Think what math you know very well. Okay, here?
5 and 3.
5 and 3.
Yeah.
You could break it into a 5 and a 3. That's what I usually go for because I like my 5s a whole lot. What would you break it into if you didn't want to do 5s and 3s? Kaylin? You could do a 4 and a 4. Work them off those doubles. What else could you break it into if you really wanted to? Damien?
6 and 2.
6 and 2. Definitely an option. 2s are pretty easy. Maybe your 6s are easy for you. Definitely an option. Natalie?
4 and 2.
You could do 2, 2, 2, and 2. I don't recommend that, but mathematically speaking, yes. I know Mason did that strategy the other day in mental math. I know Grace has done that strategy where they have done 2, 2, 2, and 2, and broken it into 4 different ways. I don't recommend that because it gets to be too much, but yes, technically you can. Mason? You could do 7 and 1. Now, 1s are pretty easy, but 7s are pretty hard. So I think for my brain, and I think for most brains, 5 and 3 is going to be the easiest. So let's break it up into 5 and 3. Remember, your 2 parts have to equal up your factors. You can't just say, I like my 5s and my 2s, so I'm going to use 5s and 2s. Because 5 and 2 doesn't give me 8. All right, now to make my equation, what do I need to start with? I like you to start with something. Technically, it doesn't matter because of our commutative property, but it's a little easier if we always start with what, Ella Harris? Our factor that we didn't break up. And in this case, that is 8. Times 8 times what, Gabriella?
5 or 3.
5 or 3. Let's go with the first one. That's our first part of 8. Plus the number that we didn't break up again.
3
Times what, Susie? 3. The other part to our broken up 8. Solve the rest of that in your notebook. Be patient. Let people have a chance to solve it. Solve this in your notebook. If you need to do another strategy to solve one of these mini equations, that's fine. That's fine. What is 8 times 5, Sam? 40. Plus 8 times 3. Now I heard Susie do this and Georgiana asked me, she said, well, can I just do my 2s and then add one more group? Yes. You don't...
Miss Miller.
Yes. Please memorize. If you do, yay, happy for you. But if you know, oh, well, my 3's are really just my 2's plus another group, do your 2's plus another group. Whatever strategy you want. 8 times 3 is what? 8 times 3 is what? You cannot just sit there. You need a strategy. I don't care what it is, but you better have a strategy. So, Dylan? 24. 40 plus 24. This is a pretty easy one to solve in your head. Some good mental math. 40 plus 24. 40 plus 24. What'd you get, McKenna? 64. So what is 8 times 8? 64. Let's go add it to our multiplication chart. We are going to be all done. Alright, 8 times 8, again, one more time, is what? 64. Give yourself a pat on the back. You know all your math facts now. Yay! So if I ask you something tricky, like 9 times 6, you are not going to look at your multiplication chart. You are going to use any strategy that we've learned so far to figure it out. Now, yes, you have a multiplication chart now in your notebook. You also, most of you have found, have one in the back of your composition notebook. Some of you do, some of you don't. Please don't use it. Please don't use it. Please use the strategies that you have learned. You have learned to solve all of those equations. There's no reason why you should just look at me like you have no clue. Cord? Yeah, that's fine. Yes. So how would our graph paper be helpful if I was going to use it to make an array, right? Okay, you're on the right track. Lucy, what would be helpful for, yep. Did I?
Don't they have like those type of papers and what it will look like?
Yep. Yep. Why else would this be good for arrays? Think about what it's already got. Bridget?
Because instead of having to draw all of the dots, it just shaded it.
It's got squaring. It's got boxes. That doesn't necessarily help us. What does it have? Cheyenne?
Instead of the dots, it has squares to be like that.
Squares? I don't care about squares. Squares and dots are the same thing. What does it already have? Tajir?
Lines.
Getting closer. Okay.
It already has an array.
How?
Because those squares that are together, they are making an array.
How? It already has rows and columns. Can you see the rows?
Yes.
Can you see the columns?
Yes.
So we're going to use this to continue thinking about the distributive property. We're going to see it. Some of you can already do this. You already know exactly what it looks like. Some of you need a little more help to understand what we're actually doing when we break apart. And so we're going to use this today to break apart arrays so we can really see what's going on when I'm doing the distributive property. Yeah?
In the group,
Sure.
we did that, but we haven't made like a
Sure. Sure. How many rows and columns? What's going to be that array? Going back to the beginning of multiplication. Brian?
3 columns and 3 rows.
Yeah, so it is a 3 by 3. If I counted all those boxes, how many boxes should I have?
9.
You guys are saying 9. Why? Why? Yes, you could count them all, but why do you know it's going to be 9? Cheyenne?
Because if you slide three times, so 3, 9, 6, 9.
Yes, if we skip count, we know that it's going to be 9. All right, let's look at number 2. How many rows? How many columns? How many rows? How many columns? What is this array? Damien? It's a what?
5 times 5.
It is not 5 times 5. Be careful. 5 times 4. Would Damien be wrong if he wrote 4 times 5?
No.
Why? He said 5 times 4, but would he be wrong if he said 4 times 5? Ella Harris? Beautiful. Number 3. What's my array in number 3, Aiden Dawson? We are all waiting on you to start paying attention because I've called on you and you're over there making swords with your pencil. So for the 3rd time, what is number 3, Aiden Dawson?
Number 3 is 2 times 2 by 4.
It's a 2 by 4 or a 2 by 4. Come sit on the carpet since I can't push you back there by your seat. Alright, so take a look at my red and blue rectangle. Again, tables 2 and 4 if you need to come up. We're not going to do anything right now. We're just going to take a look. Table 1, you're kind of far away too if you're in that back row. If you need to come up. Table 3, you should be good, so you're good to stay. All we're doing is looking. Have a seat when you're up here. We're not writing anything. You don't need to bring anything. So my large rectangle has been broken up. If I made a large rectangle array like you just did on the front of your graph paper, it's been broken up into 2 smaller arrays. And then I can find the product of the red small array and the blue small array to figure out the total. Okay? So let's look at this. This is a 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7. A 3 by 7 array. The whole thing is a 3 by 7. I don't like my 3s. I don't like my 7s. We're going to break apart. Probably going to break apart the 7s. You could do the 3s, but for this one we're going to break apart the 7s into what, likely? Nathan? 5 and 2. So now I have a 3 by 5 and a 3 by 2. Are we good with that? Yes. Take a look at my array now. This is a 5 by 3, otherwise known as 3 by 5. Do we see that?
Yes.
And then this is a 2 by 3, otherwise known as 3 by 2.
Wow.
And then when I smush them together, I get my 3 by 7. For those of you who are struggling to see that for a while, does this make it a little easier to picture what's happening when you break it apart?
Yes.
Yeah. What is 3 times 5? This array. 3 times 5. What is 3 times 5? I can tell who's memorized their 5. Who's supposed to tell me? Parker? 3 times 2? Brian? Okay. So what is 3 times 7? Yeah. McKenna?
21.
21. If I were to count up all these pieces individually, what number do you think I'm going to get to?
41.
Let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Pause. Hey, we just said 3 times 5 is 15.
Oh, it was the first one.
Let's keep going. 16, 17, 18, 19, 20, 21. This array is 3 by 7, which is 21. And if I didn't want to skip count, I could break that array into littler arrays and then count each one. Does that make sense? Yes. Alright, go back to your seat. We're going to do this next part together. Which side has 9? Which side has 9? Put your finger on your side that has 9, because your rectangle might look different than my rectangle. Put your finger on the side that has 9. So for me, I'm going to put my finger right here, because this is 9. What would I break 9 into? What would I break 9 into? Sam? Alright, so what I'm going to do is I'm going to count down until I get 5 boxes up top and then 4 below. 1, 2, 3, 4, 5. And I'm going to draw a line across. I am breaking up my array. I'm breaking up the 9 part of my array into 2 smaller rectangles. Grace. We broke it into 5 and 4. Okay, now I want you to take one color. I don't care which color. And I want you to shade in just the top rectangle. Doesn't have to take 8 billion years, just a light shade. And then with that same color, I want you to write what equation goes with just that color box. What array did I represent with my color? What array did you represent with your color? Lucy? 5 by 3. So in green, because I use green, I'm going to write 5 by 3. And I'm going to put that in parentheses. If you did not do a 5 by 3, you did something else. Look at your array. Pay attention to your array. We good so far?
Yep.
Okay, let's take the other color and color in the other half. Again, doesn't have to take 8 billion years, just a light shade. And what equation? What equation, Gord, does that represent? 3 times 4. 4 times 3, however you want to put it. Does that look familiar?
Yes.
It is the same strategy, except this is like seeing it version. Georgiana? It is break apart. It is break apart. I want you to underline with your pencil the 9, the 5, and the 4. Because that's what we broke apart. Normally when we do this, we would say 3 times 9, we're going to break into 5 and 4. We've done that, but we just did it in picture version. Pretty cool, huh? Georgiana, what's up?
So then it says picture version. We can do that picture version.
You could do that picture version. I would not recommend that though, unless you have graph paper. Because it gets really confusing if you don't have graph paper. Okay, Gabriella. All right, you have graph paper. You did not need to draw all the lines in the middle. Do I have graph paper?
No.
No. So I drew all my lines. You already have them. You're welcome.
Thank you.
I did not. Which factor would you like to break up? Think about it carefully. Think about it carefully. Because we know this equation represents 7 times 12 or 12 times 7. Which factor, Sam, which factor do you want to break up? 12. I like the 12. What would we break the 12 into? I agree with that. Put your finger where the side is where you have 12. It might be at the top like mine. It might be on the side. We're going to count to make a box that has 10, and then on the other side a box that has 2. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I'm going to draw my line to separate 10 and 2. I have 10 on one side and I have 2 on the other side. Good with that, Courtney?
Yeah.
Yeah. So I'm going to shade mine probably. Doesn't have to be Picasso, just get it done. Mine kind of looks like a Pop Tart.
Yeah, it usually does look like a Pop-Tart. It does. It looks like a what?
Alright, what is the equation of the array that you are coloring in? Raise your hand to tell me. What did you just color in? You're going to write it, not just color. So you know that that blue means that equation. Lucy?
A 10 by 6.
Now 10 by 6. It might be a 10 by 6 if you drew your array wrong. 10 by 7. Because this little bit right here, Lucy, is 10. And this right here is 7. So my green array is 7 by 10. Cheyenne, you good? What?
What if we're writing our equation in? It's kind of like the key.
Yeah. Alright, with your other color, color in the other box, and then write the equation that that array box represents. In that color, so you know that color goes with that array box. Whoever's mumbling, please stop. So now this section is what? Gabriella?
2.
2.
And
What about this one?
8. 7.
7. So what is going to be my new array for just this section? What's going to be the equation? 40?
2 times 7.
Yep. Or 7 times 2, however you want to say it. Whatever makes your brain happy. Can you see how I broke up my 12 into 10 and 2? Can you see that now? Do you see what the picture looks like now? What is 7 times 10? You should have these memorized. 7 times 10. Y'all scaring me. McKenna? 70 plus 7 times 2. You should have that memorized. I can tell who does and who doesn't. Marker? 14. 70 plus 14. That's easy mental math. 70 plus 14. You could do that in your head. I know you can. 70 plus 14, that's easy mental math. Diane, what you got? 84. So what is 7 times 12?
84.
If I counted all the green dots and all the yellow dots, what would I get? Thank goodness we know another strategy besides that. Right?
Yes.
Alright, so here's what we're going to do. With your scissors,